We're going to take a moment here to calculate what the gravitational field is on the surface of Jupiter. Now, I do know that Jupiter is a gas planet and it really doesn't have a surface, but we're going to calculate basically where the extent of what we would classify Jupiter reaches. Okay? So starting off with the gravitational force equation, so gmm over r squared is equal to the force of gravity. Now, if we just simply want the gravitational field, we just eliminate the passive mass and we're left with only the active mass. So gm over r squared is equal to the acceleration due to gravity. Okay, and at this point we're just going to plug in a few values. So starting off, we're going to start off with the gravitational constant, which is 6.67 times 10 to the 11. That's my g. I'm going to separate this slightly so that there's a difference there. And then I'm going to multiply it by the active mass, which is the mass of Jupiter, which is going to be 1.898 times 10 to the 27. And unfortunately, I didn't bring my calculator. Okay, I'm going to divide that by the radius squared, which is going to be, for simplicity's sake, it's 69.911 times 10 to the 6, but that seems pretty close to 70 times 10 to the 6th, and that's going to be squared. Okay, I could simplify things. I think I will, just to make things a little bit easier so they can get into the ballpark. This looked pretty close to 2.0. I'll leave the 6.67 because it's a little closer to 7, but not quite. So let's start off. So when dealing with exponents, I like to do this first. So I'm going to square this term, and that's going to give me 70.0 squared times 10 to the 6th squared. Okay? And the reason why I'm doing that is because I want to get rid of as many of these exponents as possible. So 70 squared stays. No, it's not 20 squared. So I'm going to leave that where it is. So that would be 70.0 squared times 10 to the 12. And the reason why I'm doing this is because I've got, that's 10 to the negative 11th. I apologize there. That should have been a negative. I did that because I wanted to do this. So 10 to the negative 11 and 10 to the 12, but that's in the denominator. This term and this term together is going to give me 10 to the 23rd. And that's going to be negative 23rd because that's in the denominator, and that was a negative 11. That negative 23rd and then that 27 is going to give me 10 to the 4th. Okay? So simplified really quickly, I'm going to have let me do this in space here. 6.67 times 2 times 10 to the 4th divided by 70 squared. Okay? Oh, now I have to think. 70 squared. 70 times 70, that's 0. That's 7 times 7 is 49, so that's 4,900. And then 2 times 6 is going to give me 12, about 13. So I'm going to say I've got about 13 over 4,900, but that's 13 times 10 to the 4th. Which is, mind you, all of this is approximately. 13 times 10 to the 4th is going to give me a pretty big number. So keep working my way out. So I'm going to have 13, 1, 2, 3, 4 divided by 4,900, which is about 5,000. So if I had 5,000, drop my zeros, so I'd have 130 divided by 5. Yeah, it's a pretty significant amount of gravity. That's how I would calculate the gravitational field of Jupiter.